Hey, my name is Katrina Bird, or my patients call me Dr. Bird, and welcome to my channel. Today we're going to talk about aminoglycosides. So, if you're interested, stay tuned. As I just stated, we're going to be talking about aminoglycosides today. So, I just want to put a quick plug in for my Instagram account. Please definitely check it out. There you can find just a quick guide to aminoglycosides as well as some dosing information. So don't be a stranger, check out my IG and let's get started. All right, so in general, I like to know where the antibiotics work. If you remember where the antibiotics work, it helps you remember what they cover. So in a couple other videos, and I'll put a link above, we talked about beta-lactam antibiotics, two of them being penicillins and cephalosporins, which work on the cell wall. Today we're going to be talking about aminoglycosides, which actually work on the ribosomes. So let's go further. All right, so we're going to just quickly review protein synthesis at a high level just so that we orient ourselves as far as what we're doing. So sorry this picture is a little bit blurry, but first we have our genetic material, which is DNA. So DNA unwinds so that we are able to transcribe it. So the process of DNA being transformed to RNA is called transcription. Once that RNA is made, it exits the nucleus of the cell. Then that's when we're able to kind of finish off our protein synthesis through a process called translation. So our mRNA attaches to, in a bacteria, 30 S subunit and 50 S subunit. It's a different when you're thinking about eukaryotic cells. And tRNA bring the actual amino acids to this ribosomal complex, and which ultimately results in a prolongation of our amino acid chain. And once we have our amino acid chain, this is called a primary structure. It goes to secondary, tertiary, quaternary structure, and then we have our protein. All right, so now let's talk about how aminoglycosides work. Okay, so the aminoglycoside actually binds to the 30S subunit on the mRNA. So remember, the mRNA goes to this kind of 50S and 30S subunit complex. So the aminoglycoside sits right there on the mRNA, so this complex can no longer, read the genetic material. So they don't know which amino acid to bring in next. And so it basically inhibits protein synthesis. Short story, aminoglycosides prohibits protein synthesis. All right, so then how can our bacteria overcome this? How can they become resistant to aminoglycoside? All right, so this is a very general kind of picture to go through a few mechanisms in which bacteria can be resistant to antibiotics. So let's start with our pump. So we have the efflux pump here. So what they can do is once the antibiotic goes in the cell, they can pump more. Basically, as soon as the antibiotic goes into the inside of the cell, it can pump it right back out. So you can have like an increased efflux of the antibiotic. The other one is on the opposite side of the spectrum. You can have a mechanism where you're not able to get the antibiotics into the cell. So decrease influx, okay? Because these antibiotics work inside the cell. The other thing is that you can change your target site. So in this case, that would be the 30S subunit. Or the antibiotic can produce enzymes that inactivate the antibiotic. So in this case, regarding aminoglycosides, what happens is, number one, you have increased efflux, because remember, this works in the inside of the cell, so you're pumping the aminoglycoside out of the cell, and that's one way in which you can have resistance. The next way is that the bacteria creates enzymes that break down the antibiotic, like acetyltransferases, or it's just one example of an enzyme that can do that. Lastly, you can change, there's a change in the conformation of the 30S subunit. So basically, the antibiotic cannot recognize its site of action and thus becomes ineffective. All right, so let's talk a little bit about specific aminoglycosides. So I put this picture with some fluid and IV because primarily these are IV medications, and I'll talk about a few exceptions as we go. All right, so just a few general principles. In order for this class of antibiotics to get inside of the cell, it requires oxygen. So its transport into the bacteria is oxygen dependent, which means that these antibiotics don't work, they won't work against anaerobic bacteria. They also don't work that well in acidic areas or environments too. Additionally, the most common side effects you worry about are nephrotoxicity, or problems with the kidneys, and ototoxicity, which is difficulty hearing. So I actually have seen people lose their hearing from taking aminoglycosides. And primarily, I've seen it in cystic fibrosis patients who have been on these medications for a long time. I also met a gentleman who had a really severe infection and had to be on this class of antibiotics, and unfortunately had significant hearing loss. And this hearing loss is irreversible. So we ultimately want to try to avoid this happening in our patients. And lastly, this class of antibiotics is not safe in pregnancy. It's category D, so D for don't use it. All right, so I have a picture of a heart, and on the left side of the heart, in the left atrium, you have these kind of reddish pockets. So this is supposed to represent infective endocarditis. I want you to keep this in mind because when you think about gentamicin in adults, one of the most common reasons why you'll use gentamicin is in the case of infective endocarditis. So gentamicin works really well with penicillins. You could also use it with vancomycin. So it gives us our most, gentamicin is the one aminoglycoside that has the most gram-positive coverage. So it's going to cover MSSA, or methicillin-sensitive Staph aureus, some coagulase-negative Staph, that's what the cons stand for, and vancomycin-sensitive Enterococcus. So when we're thinking about infective endocarditis, one thing you'll commonly see if you're having like a Enterococcus infection, you may see penicillin and gentamicin used together because endocarditis is considered a severe infection. Penicillins have worked synergistically with gentamicin. So if you remember, and I'll put the card up to review penicillins, but if you remember, penicillin works on the cell wall and it kind of breaks down the cell wall. And gentamicin will thus go into the cell and it will work on protein synthesis. So they work together to kill the bacteria. Okay. And for coagulase negative Staph, you can use vancomycin, which also works on the cell wall, and gentamicin together to fight this type of infection. It also covers aerobic gram-negative bacteria. So again, stressing that you cannot use this class of antibiotics in an anaerobic setting or to treat anaerobes. All right, so I have a picture of a lung because that's kind of what I think about when I see Tobramycin. So a lot of times I see Tobramycin used in a setting of Pseudomonas infection in cystic fibrosis patients, because when you have cystic fibrosis, you have a lot of thick mucus sputum in the lungs, and that's like the perfect breeding ground for bacteria. So unfortunately, you can be colonized with Pseudomonas. So Tobramycin can be given IV. It could also be given in an inhaled form. And so a lot of cystic fibrosis patients get the inhaled Tobramycin. So this is going to cover aerobic gram-negative bacteria, and it covers more Pseudomonas than Gentamicin. And this does not give you any coverage against vancomycin-sensitive enterococci. All right, so I have a picture of a person holding the belly because when I think about amikacin, I most commonly see it in severe intra-abdominal infection. And when I say like severe, it's like a lot of stuff there. It's with resistant bugs. This is when I typically see amikacin. So this is going to give you some MSSA coverage, and it covers strep, including vancomycin sensitive enterococcus, but it does not cover vancomycin resistant enterococcus. And sorry that this is cut off a little bit, but it will cover, just like Tobramycin, your aerobic gram-negative bacteria, including Pseudomonas. So it's a decent drug. We typically, unless absolutely necessary, the aminoglycosides aren't the first line therapy we're going to use for Pseudomonas, and it's in general not like our first line antibiotic unless we absolutely have to use it because of the hearing loss, risk of hearing loss, and the high risk of renal disease from these antibiotics. All right, so definitely check out my IG account for details on dosing, and that's all I have for you. If you enjoyed this video, please hit like and subscribe to my channel. Until next time.